Okay, the one thing we didn't do in 5.2 is dividing. So there's 3 different types of things I need to teach you here. The first one you've done before, and that is dividing. That's not dividing, that says divining. Let's try again. Ready? Dividing a polynomial by a monomial. This is going to be completely different than what we're going to do with polynomial divided by polynomial, okay? So the first one I have on my note packet is 5a squared b minus 15ab to the third plus 10a to the third, b to the fourth, and that's all over a monomial, okay? It's a monomial because it doesn't mean plus or minus. Now, if you remember the rules of fractions, the rules of fraction is you don't change the denominator. If you have a common denominator, you add up the numerators and keep the denominator. So we're going to go opposite here. We're going to split this up into little fractions. Well, that means they all had a common denominator of 5ab. So I'm going to do 5a squared b over 5ab minus 15 ab to the third, and it had to have the same denominator if we put them all together, plus 10a to the third, b to the fourth, over 5ab. And then I simplify each little piece, okay? So 5 over 5 is 1, a squared over a is a, and then the b's cancel out to be 1, okay? So the first term is a, and we subtract from that. 15 divided by 5 is 3. The a's cancel out, and we have b to the third and b underneath. Where do the b's end up? They end up on the top. How many of them got canceled out? 1 of them, so we're left with b squared. And then we add to that, well, 10 over 5 is 2. A to the third over a, well, that means 1 of the a's canceled out, and our numerator's left with 2, so a squared. B to the fourth over b, again, 1 of the b's cancel, but we're still left with 3 b's in the numerator. So that's my final answer for this one, okay? Not too bad, you just have to remember to split it up. Let's do one more of these and see if you can do it. Again, you can always pause it and try and then just fast forward to the answer and see if you got it right. So 6xy squared minus 3xy plus 2x squared y. And all of that's over xy. So again, since they all have the common denominator of xy, I can split this up into 3 little fractions, all with xy as their denominator because they have a common denominator. And then I can simplify each fraction, okay? All right, in the first fraction, we have a 1 in the denominator, 6 in the numerator, so the 6 stays. The x's cancel out, because we have an x over an x, and then we have a y squared and a y in the bottom. That means we end up with 1y in the numerator. Okay? In the next term, we have 3xy over xy. The xy's are going to go away and just leave a 3 there. And in our final one, the 2 doesn't have anything to cancel with, but we have an x squared in the numerator and an x in the denominator, meaning one of those x's cancel, leaving 1 left in the numerator. The y's are going to cancel each other out, and so this is my final answer. Okay, that's the easy part of this. We are going to do long division. Now, you might not want to write this down, but let's think back to when you learned long division. It's been a long time. Don't write this down, but this is the same pattern is going to be used for what we're going to do with polynomials. Okay, so let's say we had 5,289 divided by 21. Okay, we'd put the 21 on the outside, we'd make our little house, 5,289 would go in the middle. We'd figure out how many times does 21 go into 52. So, well, it wouldn't go in, would 2 work, 3 work? I'm going to start with 2, and that would be 42. I subtract this whole thing from that, so that's going to be 10. I bring down the 8. 21 goes into 108. Well, 2 goes into 10 5 times. So it's going to be close to 5. Let's try 5. So it's going to be 5. It's 105. Okay, great. We subtract. 108 minus 105 is 3. We bring down the 9. It doesn't go in at all. and the remainder is 39. Well, if you remember, at some point they stopped letting you write R39, and you had to do 39 over, whoops, that's wrong. I don't know how to divide. It's actually 1. We can go in there one time. I was thinking 2. So let me fix that. We multiply by 1 here, and then we get 21. And 39 minus 21 is going to give us 18. That's our remainder. And so we're going to have 18 over 21. And at some point they made you simplify. And that was going to be your answer. You could just put R. Okay? We're going to use those same steps for long division with dividing polynomials. And I will do my best to explain every step of the way what's going on here. Okay? Number 1, inside our little divisor house is x squared minus 2x minus 15. On the outside, we have x minus 5. Okay, I'm going to put my thinking over here. So the first thing I got to figure out is I need to divide x into x squared. So x squared divided by x, well, I can rewrite this. This is just my thinking over here. You don't have to write this. Divided by x is really just an x, right? So I'm going to put an x up here. And this is where people get confused. I am going to take that blue x and I'm going to multiply it by this whole thing. I don't know what that line is from. So I'm going to do x times x minus 5. Now some of you might need to have some scrap paper off to the side to do this, and some of you can do this in your head. So this is going to be x squared minus 5x. And that's what I'm going to write right underneath each term. Now here's where it gets confusing. Just like in the long division that we did up here, we're going to subtract that whole thing. So x squared minus x squared is 0, which is what we wanted. Now we have negative 2x minus negative 5x. Negative 2x minus negative 5x. Well, the minus and negative 5 makes that positive, so this becomes 3x. Okay? I don't need that 0 there, so I don't usually write it. You can cross it out if you want. The next step is to bring down whatever's next, so that's negative 15. Now again, we're going to figure out how many times does x divide into 3x. So we take the 3x and we're dividing it by x. Well, what does that give us? That gives us just a 3. So I'm going to put a plus 3 up here. And again, I'm going to take that plus 3 and I'm going to multiply it by the whole x minus 5. So that's going to give me 3x minus 15. And I'm going to subtract the entire thing. So 3x minus 3x is 0. That goes away, which we expected. And negative 15 minus a negative 15, if we take away a negative 15 from a negative 15, is also 0. There's no remainder. So this is my answer. And what this means is x minus 5 multiplied by x plus 3, if we FOIL that or box that, we would get x squared minus 2x minus 15. So we're going to use this later. Right now you're just learning how to do this. But later we're going to use this for some of the problems coming up later. So the answer is x plus 3. They don't always come out that nice. Let's do another one. Number 4 is 2y. Oh, let me see if I leave some room over here. 2y minus 1 on the outside, and on the inside, now this is what you have to watch for. Okay, it starts with 4y to the 4th, and then it skips to y to the 2nd. So I'm going to put in that there are no 0y to the 3rds. We want each exponent represented there. Then we're going to go to the minus 5y squared. The next thing that should show up is just a plain old y, and then a plain old number. Anything that's missing, we have to put that 0 in there. Okay? Now again, there's a thinking process that happens. I'm going to look at my first term, 4y to the 4th, and I'm going to divide it by 2y. So I'm going to take over here, either in my thinking or on a scrap piece of paper, I'm going to go 4y to the 4th divided by 2y. And that's going to give me 2y to the 3rd. So I write 2y to the 3rd up here. That's what I'm going to use. Again, I have to multiply that by the whole thing here, the whole dividend, okay? So we're going to take 2y to the third, again, either in your head or on a scrap paper, and we're going to multiply by the whole thing here. So that really gives you 4y to the fourth minus 2y to the third. And you can see why we needed the 0y to the third there, because we need to stack things where they belong. Okay, so this is 4y to the fourth minus 2y to the third. Okay, we're going to subtract away that whole thing. So 4y to the fourth minus 4y to the fourth goes away. That was the whole point. 0y to the third minus a negative 2y to the third gives us a positive 2y to the third. We bring down, watch your signs here, negative 5y squared. And we start the process again. I say, okay, I need 2y to the third. Again, either in your head or on a loose leaf sheet of paper or dry erase, divided by 2y is going to give me y squared. So that's what's going up here, a plus y squared. I'm going to take that y squared and I'm going to multiply it by the whole 2y minus 1. So that's going to give me 2y to the third minus y squared. Again, don't forget we're subtracting this entire thing. 2y to the third minus 2y to the third gives us nothing. Negative 5y squared minus a negative y squared, well, that makes that a positive y squared, so this is negative 4y squared. Bring down, positive 2y. We're going to do that whole process again. We start the process yet again. Let me think of a different color here so we can kind of follow the colors as the process changes. So this time I'm taking negative 4y squared and I'm dividing it by 2y. Well, that's going to give me a negative 2y this time. So up here I'm going to do negative 2y. I'm going to multiply that entire negative 2y times the quantity 2y minus 1. So it's going to give me negative 4y squared. Negative 2y times negative 1 is a positive 2y. Don't get too happy, we do have a remainder on this one. We're going to subtract away each thing. Negative 4y squared minus negative 4y squared goes away. Positive 2y minus positive 2y goes away. So we actually have 0 here, but we're not done the problem. We have to bring down the plus 4. Well, can 2y go into a plus 4? Nope, that's going to be our remainder. Our remainder is 4. Now remember what we did back at the very beginning. Whenever we have a remainder, we put it over the divisor. Well, what's our divisor? 2y minus 1. So we're going to put plus the remainder, 4, over what we were dividing by, which was 2y minus 1. This mess here is our answer. Okay? We're going to do 2 more examples, so it's kind of up to you how much more you want to follow along. I'm going to pause and start a second video for synthetic division. But we're going to do 2 more long division problems. Okay, this time I'm not going to write all my thinking off to the side. I'll talk through it, but I'm not going to write it. So I have 3x plus 1 on the outside. And on the inside I have 6x to the fourth plus 5x to the third, making sure I'm not missing any x's, 4 to the x to the fourth, x to the third, plus x squared, minus 3x, plus 1. There was nothing missing, so I didn't have to put a 0. First thing I do is look at my 3x and my 6x to the fourth. I know it's going to be a 2, and it has to be x to the third. I take that and I multiply it by this whole thing. So that's going to be 6x to the fourth plus 2x to the third. I have to subtract away the entire thing. So 6x to the fourth, subtract 6x to the fourth, goes away. 5x to the third, subtract away 2x to the third is going to give us 3x to the third. Okay? Now bring down. We're going to bring down the plus as well as the letter. So it's plus x squared. Starting the whole process again, I'm going to look at my 3x and I'm going to divide it into my 3x to the third. That's going to go in one time and then an x squared. Again, I'm going to take that x squared, I'm going to multiply by the entire quantity. So that's going to be 3x to the third plus x squared. I'm going to subtract this entire thing away. So 3x to the third minus 3x to the third, 0. X squared minus x squared, 0. I'm going to bring down, and this case is a little bit different. I'm going to bring down that negative 3x, and I'm going to bring down that plus 1 also, because we're going to need both. You could figure it out later that you needed it, but it's up to you. So this time, the only difference is I have a negative 3x divided by a 3x. That means this has to be negative 1. And so then we go negative 1 times 3x, that's negative 3x. Negative 1 times 1, that's negative 1. Again, be careful. We're going to subtract the entire thing away. So negative 3x, subtract away, negative 3x goes away. 1 minus a negative 1, though, makes that a 2. So we have a remainder of 2. So on the end up here, our remainder of 2 goes over the quantity we were dividing by, which was 3x plus 1. This entire mess is the answer when you divide. Let's do one more division, long division problem. We have x plus 3 divided into x to the 5th. Now there's no x to the 4th in the problem, so I have to write 0 x to the 4th are there. Minus 7x to the 3rd. There's no x squares in the problem, so I have to put 0 x squares plus x plus 1. Let's start dividing. X into x to the 5th goes x to the 4th times, multiplied by the entire thing. So it's going to be x to the 5th plus 3x to the 4th. Now this is where you got to be careful with your negatives. X to the 5th, subtract away x to the 5th is fine, but then we have 0x to the 4th, subtract away 3x to the 4th, so that's a negative 3x to the 4th. Watch that. We're going to bring down a negative 7x to the 3rd. So x goes into negative 3x to the 4th, negative 3x to the 3rd times. So that'll give us negative 3x to the 4th minus 9x to the 3rd. Again, we're multiplying by the entire thing. We're subtracting away the entire thing. So this gives us 2x to the 3rd. And we're going to bring down 0x squared. 2x to the 3rd divided by x is going to be 2x squared. Multiply the 2x squared by the entire quantity will give us 2x to the 3rd plus 2x squared. Take away everything. That means we have a negative 2x squared. Running out of colors. Bring down x plus x. So negative 2x squared divided by x is going to be negative 2x. Take that negative 2x, multiply by the entire quantity that you're dividing by. That's going to be negative 2x squared minus 6x. Subtract away. That makes that a positive 6x, so we have a 7x here. And then we have to bring down, I don't know what other color I have. Purple. No, I just did purple. 1. Let's see. Yeah, it's a little different. A plus 1. What goes into that? 7. Wow, I really messed up on my answer key. Where did I get that from? Oh, nope, I messed up on here, didn't I? 2x to the 3rd, bring that down. Uh-oh. When we multiplied this here, I made a giant mistake. Let's fix it. I'm not going to go back and re-record the whole thing, but I'm going to show you my mistake. When I came to here, I'm hoping some of you saw it, and I took this 2x squared and I timesed it. I'll get rid of this because we don't need it now. I messed up. And I times it by a 3. That should have been 6x squared down here. So this should be a 6 here. All right, so that means we really have a negative 6x squared, bring down the x. That means we need to multiply by a negative 6x. That's totally different. That gives me negative 6x squared minus 18x. Oof, this really messes things up, doesn't it? When we subtract that away, that makes that a positive 18x. So we really have 19x here. Bring down the 1. So then 19x divided by x is 19. So now we have 19x, and then 19 times 3 is 57. Holy crap. Subtract that all away, and we're left with a negative 56 as our remainder. The remainder simply gets added onto the end, and it gets written as the numerator with the denominator of what we were dividing by, which is x plus 3. So this is really a mess. This is our answer. I'm going to pause here. This is not really the end of 5.3. 5.3 has a second part, but I want you to be able to pause, take a break, and come back and do synthetic division. So I'm going to make these two different videos.